Hi everyone, today we're going to talk about absolute value functions and their transformations. Basically I have two objectives. The first one is to graph absolute value functions and then be able to graph translations and dilations, I should say, of absolute value functions. So first of all, quick review. The absolute value of x. It's what we call a piecewise function, which we'll talk about a little bit later more formally. And I'll write that out. Piecewise, obviously it's divided into three pieces. One is if I'm putting a negative number into the absolute value of x, I make that negative number negative and therefore it becomes a positive number. If I put a 0 in for x, I get a 0. And if I put a positive number in for x, I simply get that number back. Right? So effectively it's the function that makes everything positive. Okay. All right. So let's go ahead and graph the absolute value function. So again, a function is simply something where I have an input and an output. Here are my inputs. My output is going to be whatever I get. It's just notation. I could have used y equals absolute value of x and it would have been fine. Okay, so first things first. We basically have three functions. Okay, the first function is the line negative x. The second function is the point 0, and the third function is the line x. Okay, so the first thing I can do is graph the line y equals x. That's all this is. This is the line y equals x. But I'm only graphing it for the values of the positive values of x. So it's like graphing that line, that horizontal, or that diagonal line, but I only graph it for positive numbers, numbers to the right of the y-axis. Okay. Then I graph 0. Okay, I can just put that in kind of by hand here. I graph the number 0. It has to hit 0. Okay. And then finally, I graph the other one, and the other one is the line y equals negative x, but I only graph that in the area to the left of the y-axis. Okay, typically this line would have kept on going, but what we end up with here is a V shape. Okay, two diagonal lines going up in both directions. Now we can use calculators to graph these too. This is from the function, the program Grapher, which you'll find on any Macintosh if you go to the Spotlight and you search for Grapher. Okay, and I graph the function absolute value of x, and you can see indeed it is a v. Okay. All right. So translations of the absolute value function. So we're going to learn how to graph different versions of this. Okay. Here's the original function f of x. If my new function is the absolute value of x minus some number h, okay, plus some number k, right here, what that's going to do is it's going to move the absolute value function to the right h units and up k units. Now, something to take a look at here, right, is that this, right, minus h moves it to the right, okay, whereas plus k moves it up. It's kind of backwards, right? So plus h would move it to the left, and minus k would move it down. So it does go kind of backward. The x's always work kind of in the way you don't expect them to. It always works in the opposite direction. So here's an example, and we'll learn how to graph this in a moment, but this is an example that I pulled from the program Grapher. Here is y equals the absolute value of x. That's our what we'll call our parent function. And then here's our function y equals the absolute value of x minus 3 plus 2. Small interruption there. So what we're saying here is that when I have x minus h, that's going to move h units to the right. Okay. So if I want to move to the left, this would have to be x plus a number. So plus moves to the left, and minus moves to the right. Okay. When I add the number outside the absolute value, it moves in the direction you expect. So plus 2 will move up, minus 2 would move down. So here's my function. My original is absolute value of x. My new one, x minus 3, that moves the absolute value function to the right 3 units, and plus 2 moves it up 2 units. So here's the picture. In order to graph these things, we're going to identify the vertex. That's going to be at the point hk. We're going to plot one other point on the graph by choosing a value for x, finding a y, and then using symmetry to plot a third point. And then the third thing we'll do is connect with a v shape. Okay, let's do it. So here's the graph. We're going to graph the absolute value of x plus 1 plus 3. Here we go. First things first, we find the vertex at negative 1, 3, because this is x minus 1, or minus x minus k, h, pardon me, x minus h, and really this is like x minus a negative 1. That's what we're looking at. But minus a negative is the same as plusing a positive. Okay? So we have x minus a negative 1, so x plus 1. All right, so the x value for the vertex is negative 1. And then we add 3, and that's pretty straightforward. Okay, so the vertex, the h value of the vertex is always the opposite sign of what you see here. So x plus 1 gives us a negative 1, and plus 3 gives us a positive 3. The vertex is right here. Good. That's step 1. The next step is to plot another point on the graph by choosing an x and finding a y. I decided let's choose the number 1. Okay, that's a nice number to choose. The number 0 is always a very nice choice. It's very easy to do. So I plug in 1, and I get 1 plus 1 is the absolute value of 2, plus 3, so we get a value of 5. So the second point I'm going to graph is 1, 5, the point 1, 5, and that's right here. Good. The next thing I'm going to do is plot a third point using symmetry. So from here I went over 2, over 2 and up 2. So from here I'm going to go to the left 2 and up 2 and plot another point using symmetry, because I know these v's are all really nice and symmetric. And finally, the last thing is to connect into a pretty picture. Okay? And we get the v. Okay, so we're going to get 3 points and turn that into a v shape. Okay, next is dilations of an absolute value function. Now a dilation is just a stretch or a compression of a graph. And it's going to look like y equals a value outside the absolute value times the absolute value of x. Okay. Now you will see, and it is possible to graph things where a is on the inside of the absolute value of x. Okay. As I was saying, we can always, it is possible to graph absolute values where the a is inside the absolute value, but we're not going to deal with that right now, and that's okay. So here's how it works. If I have a function, and the function is y equals a number times the absolute value of x, here's how it works. If that number is less than 1, so it's like a fraction less than 1, the graph is going to be made flatter and wider. Okay, so it's like, if the a is greater than 1, so it's like 2, 3, 2.5, anything like that, then it's going to be made taller, okay, taller and skinnier, okay. And if a is negative, okay, the graph will also be pointed downwards rather than upwards. Okay, so if it's negative, but it's I was going to say greater than 1, but less than negative 1, then it gets taller and skinnier. Okay, and if it's negative but it's closer to 0, then it's going to get flatter and wider. Okay, so here's a picture. Here's the absolute value of x function. Here's y equals 1/2 of x, so it gets flatter and wider. Okay, because 1/2 is less than 1. All right. Here's the absolute value of x again, and here is negative 2x. So it's taller and skinnier because 2 is bigger than 1, but it's pointed down because there's a negative out in front. All right, so that's kind of how these dilations work, and you need to have this kind of idea in your head. Here's how we're going to graph things with a dilation. Okay, and this is actually with a translation and dilation. And notice, wow, they are the same directions as we had before. Okay. So there's really no new work we have to do here. It's just going to be that the computation is going to be just a little bit more complicated. So first thing we do is identify the vertex at the point hk, and hk is in the same spot. Okay, here is h, and here is k. Now notice it's x minus h plus k, so our vertex should be 1, 3, and there it is. Okay. All right. Next thing we do is we plot one other point on the graph by choosing an x and then finding a y, and then use symmetry to plot a third point. All right, I'm going to choose that lovely point with x equals 0. So if I plug in x equals 0, I get negative 2 times the absolute value of 0 minus 1 plus 3. Now the absolute value of 0 minus 1 is 1, so it's negative 2 plus 3 equals 1. So the point I'm going to plot is 1, 3, right there. Second thing I'm going to do is, or the next thing I'm going to do after that is I'm going to plot another point using symmetry. Here's my vertex up here. I went over 1, down 2. Now I'm going to go over 1 in the other direction, down 2, to plot my other point from symmetry. There it is. Now I have 3 points, and I'm ready to graph. Voila. Okay? And that's it. So when we talk about absolute value functions, for this section, what we're looking at is the basic one is a v, okay, and after that, the v's are shifted around and sometimes squished and sometimes pointed downwards, okay? And that's about it. All right. Thank you, guys.